Test? Okay, I'm amplified. I wish I had this one here, but so I'm going to have a bunch to cover here. I'm not sure if I'm going to have time for questions. I'll try to leave time for a little bit if I can't really see people in the audience very well, so if you want to move forward, that's great. But I'll leave room for a little, but if people want to talk to me in the hall afterwards, we do have a 15-minute break at the end. So the thing I'm going to talk about is a kind of different approach to structuring large, or at least to structuring our programs in general, that you probably haven't thought about and probably haven't learned in courses or books or other things. There's a concept about how we could arrange programs called multiple dispatch. There's another, even less known one called predicative dispatch, and I'm going to present both of those principally as the concept itself, but as by way of illustration, there's a particular library that I've created that you are more than welcome to use. And in fact, if you take a look at the project at the GitHub page, or you can link to it through the thing that's on PyPy or various other ways, basically these slides will be there. I gave an earlier version of this talk at PyCon Africa last year, and those slides I know are already included with the repository, and I'll make sure that these are in the near future. But let's move on to some examples and the idea that's behind it. I want to briefly acknowledge my employer. I work for a labor union called Service Employees International Union, or SEIU, and they're paying for me to come here, and they're wonderful people. They're one of the largest and most progressive labor unions in the United States, and actually a little bit beyond the United States, but principally there where I live. And it's wonderful. And of course, I want to acknowledge PythonAsia, which has been such a wonderful conference. I'm going to start by presenting a kind of hypothetical example. It's something that could be programmed using my Gnosis dispatch library, but in particular, it illustrates some concepts of why you might want to structure your programs using this multiple and predicative dispatch concept. The next couple slides aren't real code. I mean, they're real code, but they're not, the underlying implementations aren't actually something that I distribute with the package. Towards the end of this, depending on exactly where I decide to break, possibly for questions or simply because I'm out of time, I'll present some examples where all the code is genuinely in the module as examples, but they're a bit more toy, the later stuff. The idea here is, though, that many of you, most of you, I think probably know at least what is object-oriented program, and you may know something about other styles of arranging your programs, such as functional programming techniques and other things. This is different from all of those, and I think for a variety of cases, it provides more elegant APIs and interfaces and easier extensibility without a lot of the spaghetti code and tangled things that build up as projects and libraries get larger. Let's look at some examples. So the hypothetical I'm presenting here is, imagine that you have this library, an initial version that is going to be extensible, that some do-gooder in the free software world has created, that is called world data. The idea here is that there are a variety of questions you might ask, for example, at a national level of different countries, although even for the example, it need not be exactly at a national level. And I showed those on the previous slide, a couple examples, and we'll see those in some later slides, that we would want to ask questions like the income and morbidity and the exports and demographics of a particular nation, for example, that could be contained in this module that I or somebody else may publish. But the virtue here of this structure that we're going to see is that this is very extensible, but it also keeps, as it's extended, a completely uniform API, and yet it allows addition of new components to it within a consistent and non-complicated API. So you imagine first that everybody can see the code. It's a little bit small, but it's a big screen too. So from this module, world data, we're importing a couple things. The main one is this object nations, which is what I call a dispatcher. We'll see a little bit more of that and how it's constructed. The other is this something that's called place. It's hypothetical, but this could be a name tuple, it could be a data class, it could be a regular class from which you might inherit and has various other capabilities. But the point is, it's just something that expresses a particular type that can be checked within the framework of the library. So one of the functions I mentioned that might exist is this demographic function. This is a thing that answers questions about the demographics of a particular nation, for example. We're going to enhance that function demographic. So we're not inheriting from a class or something like that. We're actually rewriting the function in many ways. But we use this decorator at the beginning, nations, to indicate that we're doing what I describe. And we'll see how it's used in a moment. It's basically creating and extending a namespace, but then also having some intelligence about the dispatch when we're calling that function. So in this first instance, I'm defining a implementation of this demographic function that will take as a first argument a something of the type place, which, as I said, is a data class or a regular class or something else. And then you see that funny, ampersand symbol, like and in various languages. And we say that if the ISO 3166 attribute of the place object, which is something that can have attributes, obviously, happens to be pH, then we'll have this particular implementation. In this case, there's a certain URL for the statistics agency of the Philippine government, and we will get an API key that gets us access to it. And we'll do a variety of other steps, which aren't shown here, but that would allow access through this web interface that hypothetically the Philippine government provides. This is why I have water here. And then we'll return some demographic data. And I don't know what particular structure this is, but this is something that can hold a bunch of information inside of it, such as the data classes and so on I mentioned. But then we can create another implementation immediately afterward. And we, again, use the decorator nations, indicating that we're putting this other implementation within this namespace nations. And in this case, the first argument is going to be a string rather than this other kind of class. And the string is going to exactly equal the string Malaysia. And in that case, there's a different implementation that's going on. In this hypothetical, there's a database that allows access by the Malaysian government, and you get credentials and you make a database connection and you do various queries, but then you return the same kind of thing, this demographic data that describes information about that particular company. None of this is, of course, specific to this hypothetical that I'm presenting. You could do it with any kind of domain that you might want to query. Let's present one more implementation. We're going to see an outline of what this enhanced namespace looks like in just a moment, and we're going to show an example of utilizing it to give you more of a feel. But I want to create one more for a particular reason. Again, we start with the decorator nations, and we define, again, the very same function that we've been defining several times. In this case, place, again, is a string, and again, that string is equal to Malaysia. But we've introduced another argument called source, which is an authority object, whatever that is. It's, again, some sort of type in Python that represents information about how you get data from that particular authority. And here we have a different implementation. So the nation info is using the fetch raw data method of this authority type of object, whatever that is. And this might be valuable because if you wanted to know demographic information about the Malaysian government in this example and the preceding one where we had a different implementation with somewhat different function signature to it, this might, for example, use different reference sources. You know, the United Nations provides some data, and APEC provides some data in the World Bank, as well as in the initial implementation the Malaysian government might. So what's going to happen here is we have these many implementations of the same function, but depending on the way that you call that function with whatever particular data types and whatever particular predicates, such as, you know, equaling the string Malaysia, are applicable, it'll choose the most relevant function as the way that you answer that question. So here, and this is more or less really what it looks like within this Gnosis dispatch library, you can get a string version of this now enhanced nations namespace object, and the string just tells you that this is a thing that has 16 functions bound to, in this case, 1,348 implementations. This is not actual, but hypothetical, but we'll see actual examples. And then when we want to describe more details about what's going on with that nation's namespace, we get a summary screen that gives information. So there you can see that there's a couple ellipses within this, but the idea is that there are multiple functions, 16 in this case, and each of those may have many implementations, whatever, you know, 1348 divided by 16 comes to, roughly per different function name. So for income, you know, we might take one particular signature where it could be any kind of thing, but then the name attribute happens to be Japan, or it might take a place object and then, et cetera. And then for demographic, you can see the examples that we just defined, and this would be like an enhancement of what you had already imported at the start. So if you're passing a string, and that string is exactly equal to the string Malaysia, we would do different things depending on whether there was also a source argument and use those different function implementations in the various cases. So let's take a look at calling this nation's namespace object, or in a way that looks like we're calling a method. It's technically not calling a method, but it sort of doesn't matter what you're doing. The point is that you call a function, you access some particular name that's going to give you information. And so in this example, we're first defining this place object, which again, it's, you know, it's a name tuple or it's a namespace object, it's a regular class, it's something else, but it's something that can be initialized in the manner that's shown on screen. And then when we call the demographic function with that particular kind of object, it knows which implementation to utilize in order to return the relevant data. And in this case, you know, it could be this demographic object that's being returned, which again is whatever kind of class, but it has a variety of information about demographics of the Philippines. And then in the, you know, truncated, the elliptic example below, we call it instead with the argument Malaysia first, but here we're getting the data from the World Bank, and it would be some other demographic information, which would of course differ if you didn't pass in the source or if you passed in a different source, and we would have different function bodies for each of the different ways that we might go about calling that same name. So you see that we don't need to do any inheritance, which is kind of nice. And we just build up this namespace using the very same relatively limited number of names of, you know, functions we want to query, kinds of questions that we want to ask about different kinds of data where we're roughly asking the same kind of question of it. Now, this isn't completely new. I did this in a Python module, and a number of people have in the past, like 20 years ago, including me, written other multiple dispatch libraries for Python where it will look at the varying arguments that are passed to a given name and make a decision about what implementation to utilize in these various cases. But most of them were just multiple. They didn't have this notion of a predicate that you've seen in a number of the examples below, where we would have the ampersand and then we would indicate some property. It equals this, or it could be, the variable is less than this or more than this, or you call a, function that's going to return true or false, and that will make the decision about where you want to dispatch to in the code. But parts of this are not special to my library and not special to Python. There's a whole bunch of languages where you have something called function overloading. So here's a quick example from C++. People don't necessarily have to know C++, nor do you have to know the even more obscure language, not obscure, but the less known language on the next slide. But the point here is we're doing something that is similar in concept to what I just set up with this nations namespace object. I'm defining a number of implementations in C++ of a function that is called vol, for like volume, and of various kinds of three-dimensional shapes, like a cube or a cylinder or a square prism. We are defining different implementations. They're all very, toy implementations in this case, but they're taking different kinds of arguments. So the first one just takes a single int, the second one takes a double and then an int, and the next one takes a long and a long. And you can see in the, sorry, I can't see it without my glasses. I'm being given time indication of, oh my goodness, okay. I am definitely not going to get to everything that I could talk about. That's okay. We're good on time. And do people want to ask questions at this point? People raise your hand if you feel like anybody does. Okay, I'm going to probably talk for the 10 minutes then. But you can talk to me in the hall and so on afterwards. So we have this example in C++ where we're doing something analogous, but we're only looking at the data types of the arguments that are passed in. And you can see that we're calling that with the various kinds of arguments, and we can compile the C++ function, and you call it with different kinds of arguments, and you get the different results, which call the different function bodies. In 10 minutes, I want to talk just a little bit about what it means to be a data type. And it's not what you learned in school. You learned that data types are these sort of fixed collections of types that are provided by the language, which generally match the computer architecture on which you're working. So you think, bytes are 8 bits and words are 32 or 64 bits. And so you have these data types like ints and floats and complex numbers that have those particular lengths in bits, or perhaps there are arrays of those particular things. In the first paragraph, I'm giving some notation that's from Go, but it's similar in many other languages. And those are data types. Those are expressions of the particular kinds of values that are named in that particular way, but it's a bit arbitrary and tied to some particular computer architecture where those things are true. And there has been a lot of architectures that have the same conventions for a number of decades, but it's not really in the concept of a data type. You can have a unsigned integer of 8 bits that's a number between 0 and 255, but it's just as much a data type to have a number between 1 and 100. It just doesn't match the hardware as well, but conceptually it's just as clear. Okay, here's a Haskell example that creates this idea of a small integer, and people don't necessarily know Haskell, but you can actually kind of read it okay. If that number happens to be in this particular numeric range, then, fine. We're just going to return the thing it is, the number. If it happens to be larger than that, then we're going to clip it to a particular point, and if it happens to be negative, then we're going to make that an error condition. And this is rather concisely and elegantly in Haskell a way to express that new data type that I've just talked about of a number between 1 and 100. But we can do it in Python too. It's a bit more verbose, and there's not quite the elegance to it, but Python certainly has that capability. We do these is-instance checks, and we raise value error in certain cases, and otherwise maybe we do the clipping. But we essentially get exactly the same behavior that I just showed more concisely in Haskell. So we have this new type of data, and that could be used, for example, in the Gnosis dispatch library that as I showed in the previous examples. But, here in Python, we probably want to do some more too, that it's not just enough to have a small integer, this one between 1 and 100. We want to be able to add a couple of them together. So we have to define some more dunder methods. And maybe we want to define the radd and the mul and other dunder methods to do special things with this data type. But it's a perfectly good data type, and it doesn't have the exact constraint of the machine bit length of the various types. Sure, that's a thing we can do in Python. So in general, what I'm saying is that a data type isn't actually the hardware of the machine you're working on. It's a predicate. It's a property of the data that you want to work with. And any property should be expressible. This is what the library does. I'm not going to have time here, obviously, now to go into a lot of detail. But we can define by using these predicates exact data types, the thing that fulfills any particular predicate, however complex. I mean, we can put the body of the predicate into a separate function that has as much logic as we would like to define what constitutes that particular data type. Now, this is a bit contrived, but it is that say 5? But I have a bunch of implementations here, and these are just regular functions. These aren't yet using the Gnosis dispatch library of different ways that we might test whether a number, an integer, is prime. And these various functions have, varying names as we might write. So depending on if a number is very small or medium-sized, whether we want to do a probabilistic check. But then there's even a kind of funny concept where you can ask about the primality, called the Gaussian prime of a complex number. And there's a variety of things that we might do in different instances to test for whether a number is prime. Well, we have to make a decision of which one of these functions we want to call. We could do it a couple different ways. We could have a big if-else kind of statement here, and if certain things are true, i.e. predicates, then we call one or the other implementation that I just showed you. We could do it with this match statement where we're sort of utilizing the data types a bit more. As we saw, that data type is a kind of arbitrary notion, but you would have to define all of these data types, small int, medium int, and et cetera, complex number. I mean, some of these are already given to you by Python, but others you may want to specialize more. And then, call the various implementations in the various cases. This is okay. You can do this. You could also do it by defining all the data types as classes and creating the same isPrime method for the various classes, and then give various answers, as a method of those various instances of those various classes. That's fine. I argue that it's more elegant, even for this kind of toy case, to utilize this Gnosis dispatch or something of the same type. So we can do that much like we did with the nations, but this code is actually in the library if you wanted to go take a look at the repo or download it. So we're defining, is prime for a number that is between 0 and 2 to the 16th. And in that case, we utilize one particular implementation. Otherwise, maybe it is between 0 and 2 to the 32nd in this case, but the earlier one is going to win for my number 17 that I'm testing, because that is going to be called first. They both fulfill the predicate, they're both integers, but the first one's going to win in this case. There's also some syntax in the library where even though the thing that you're decorating has a different name, you're able to say, no, we want to bind it to this same isPrime name. That's fine. So we bind a whole bunch of names, there's some more of it, for these various predicates that we're expressing about the size and type of the number that we're checking. We will call the various different implementations. The implementations could, of course, be here in the body that we're defining rather than calling something we imported. And so we get this situation where we have many implementations of this same function called isPrime, and just calling the function will make the decision of what is the most relevant implementation to call by looking at the types of the arguments that are passed in. But you get this uniform interface, and moreover, if I hand you my nums library that I've created that has some functions, I've mentioned isPrime, but I also quickly created an isTwinPrime function in the same manner. You could extend this. You can add, whatever new mathematical number theory functions you like, and you can, moreover, create as many different implementations of each of those functions as you like, as they pertain to different numeric domains or various, numeric ranges where different algorithms are more efficient than others. And it's all contained in the same namespace object and just a few functions that you want to call. I go through some more details, but I'm down to the under 5 minutes point. But we call it, with these different numbers, it winds up calling different implementations in the different cases and giving the appropriate answers. This is just a digression about the fact that Miller-Rabin probabilistic pseudoprimality testing is very reliable, even though it's probabilistic. And, we do tests about the Gaussian primality of complex numbers and a variety of things in the examples, which obviously I'm not going to have time to talk about in detail. There's a couple lies I told you at the beginning. These are very small white lies, and I think I have about 2 minutes left that I can... 0 minutes left? Okay, I have 0 minutes left, so I will stop. You can look at this last slide. You can go look at the module. The lies are basically just that you have to use this from future import at the beginning, and also you actually have to create a few objects that you're actually using in the dispatcher if those classes aren't known to the dispatcher otherwise. But that's a very small API detail. And you can do that. And then that's actually the end. I hurried up, but...